Hello, everyone. My name is Denis, and I am lead on developer experience at Tendermint. And this is going to be a very introductory workshop on basics of building blockchains in Cosmos. So I'm not going to share my screen. So you should be able to see my screen now. So Cosmos is all about building blockchains and connecting them with a protocol called IBC. So there's a framework called Cosmos SDK, and I'm gonna demo you a tool. You might already be familiar with it, called Starport, which is a tool for is a companion tool for Cosmos SDK that streamlines development of blockchains. And I'm gonna show some features, maybe some things that you don't know about this tool. So let's get started. So the first thing we do is we need to go to the GitHub, GitHub/Tendermint/Starport. So this is the repo of the tool. And there are several ways you can use Starport. So first is you don't have to actually install anything on your machine. You can just click this button and it will start on the service called Gitpod, which is a very convenient service because what it does essentially is it provisions a container with a tiny Linux machine and a Visual Studio Code editor, and we have Starport pre-installed there. So you don't really need to do anything. You just press a button and you got a whole development environment set up, and you can actually use it from an iPad, for example, as well. So when it opens, you see that it has a terminal, and you can actually use it this way and has Starport already pre-installed. You can do anything here, and we're going to use this tool later in this workshop. But of course, most likely you also want to install it locally. So you can follow the guide. I mean, it's not even a guide; it's just a single command which you execute in the terminal. So curl https get starport network /starport bang pipe bash. So what this command does is it essentially downloads the binary of the latest version of Starport and installs it locally on your system. So after that's done and you have Starport binary, now you can use it. So let's see what it has available. So Starport has a bunch of commands, and the first one that you'll most likely want to use is Scaffold the New Blockchain, right? Because Cosmos is all about building blockchains that are specific to a particular application that you're building. So let's do just that and scaffold a new blockchain. We'll creatively call it chain, and it will start the process. While it's doing that, let's open the Getting Started guide. I think it's a very kind of concise and beginner-friendly guide about how to like really get started, and we're going to follow it, and I'll try to describe everything we're doing. So now that the chain is scaffolded, we can open it in an editor. And let's see what Starport created for us, right? So we have probably the most important directory that we're going to be working with is X, and X contains modules, right? So Cosmos SDK is a modular framework, and every bit of functionality is stored in a particular module. The reason for this is because it's very helpful. It makes it easier to share functionality. So, for example, if someone built a DEX as a module, you could import that module into your blockchain, upgrade it, and now you have a DEX. So it's not a monolith, it's a collection of modules. So by default, Starport scaffolded a module called chain, which is the same as the project name. But it also created other things, right? So app is this directory that essentially wires everything together, and we don't need to worry about this directory at the moment. CMD contains the binary that will be built when you compile the chain, right? So the whole blockchain that you create compiles down into a single binary. In this case, it will be called chain D. And yeah, you can customize behavior of this binary as well. In the docs directory, we actually scaffold OpenAPI documentation, and we're going to see it in action a bit later. Proto files are really important because protocol buffer files is how you define both data structures and Cosmos SDK messages and queries. And essentially, whenever you start building your functionality, most likely you'll start by writing proto files first. Testutil is a helpful utilities for testing used by the test scaffolded by Starport. And Vue is a front-end application that is scaffolded as well. So let's start with the process of building something with Starport. So in this very simple example, we're going to be building a blockchain, and the purpose of this tutorial is to kind of figure out how the whole life cycle of a transaction looks like, right? So in Cosmos SDK world, the way blockchains operate is they have a state, right, which is represented as key value store, and users of this blockchain broadcast transactions. These transactions are signed, and they contain one or more messages, and these messages affect state, so they act as state transitions. So that's how the data is changed on chain, and the way you get the data back is you query your blockchain, right? So let's go through a very simple hello world to see the blockchain returning something back. But before even we do that, let's build the chain, and we have Starport serve command, which does great many things. So initially, it's going to build proto files into pb.go files. Once it's done doing that, it will install dependencies from GoMod. It will actually build the binary, the chain D binary from here. It will install it. Then it will use information from config YAML file to initialize a node locally. So you can see that it's done that already. And it started the node with two API endpoints, as well as auxiliary services. In this case, it's a faucet, right? So we can visit 1317, which is the main API of your blockchain, and you can see OpenAPI docs from the docs directory, right? So all the available endpoints, you can query them here. And so, for example, the bank module has params endpoint. I mean, right now the blockchain is pretty much empty, but if we query, we can get params, for example, that default send enabled is true, etc. Right? So you can make queries to your blockchain from here. So the first thing we want is to actually get something custom from our blockchain to see that it's working, right? So we need to see hello world. So while the chain is running, we can actually start implementing our very basic but still functionality. What I will actually do is create a new module, because every bit of functionality should probably live in its own module. So Starport has a command for that. Starport module create, let's call this module a blog because we're building a blockchain. And it's going to start building. You you can see that in the X directory, we now have one new directory called blog. And it's the same as chain. It's an empty module with boilerplate code so that you don't have to write all of this by hand. So it's pretty standard Cosmos SDK stuff. But it saves a lot of time not having to write it or copy it, make changes. So you can also see that it's automatically rebuilding the chain, and we can actually continue. So since we just want to get something from our chain back and see kind of the whole process of querying, let's see how Starport can help us here. Right, so Starport has a bunch of commands, and one of them is query command. So scaffold Cosmos SDK query looks appropriate. So let's do that. So Starport query, and our blockchain will have posts, right? And we know that each post will have a title and a body, very simple, right? So we just pass title, body. By default, Starport will scaffold this query in the chain module because it defaults to the module with the same name as the project name. But what we want is to scaffold it in a particular module called blog. So we did that. Okay, I missed the S. Happens. So now it's scaffolding the query. And it's automatically rebuilding the chain. So we can already see what has changed here, right? So we had an empty proto file with nothing, right? But now we've got a posts RPC with gRPC HTTP API endpoint, right? This is the endpoint on which our query will return data. So if we, well, let's wait for the blockchain to actually build, but we already have a message with a response type of title and body, and it already gets compiled into pb.go files. We don't actually need to have Proto-C installed. It's doing it automatically. So if we now visit this endpoint from the query.proto file, what we'll actually see is not implemented. Well, first thing, when you create a new query, you need to wire up the gRPC HTTP routes to your application. So for query, Starport doesn't do that for you because query is a more low-level command, but it's good to know like where you actually need to do it manually. So in module.go file, you search for gRPC routes, and here you actually need to register. I'm just going to copy and paste from here, but what it essentially does is it takes this register query handler client and mounts all the queries to our blockchain. It automatically will import context and rebuild the application. You only need to do it once, and only if you haven't scaffolded any types, for example, previously. But this effectively mounts all the query endpoints. So let's see where actually the querying happens, right? So each query from the query.proto file from the query service points to a particular method in the keeper package. So in the keeper, we have gRPC query.posts file, and this function actually runs when we query, right? And right now it doesn't return anything, but we know that it can return title and body based on what we have in the proto file, right? We have title and body. So let's return something from here. So let's say title, hello, and body Starport. So now if we save and rebuild, we will actually see what has changed. So of course, this is static data, nothing interesting here, but at least we will know that the chain reacts to our changes in the source code, and we kind of build up from that. So now if we go back to the same endpoint and we start, we'll see hello Starport. So if we change here, the data is returned differently, so we know that there's contact with the chain, right? Really simple, but still kind of helpful. And we also, with the query, we got a CLI command as well. So if we use the binary, so since Starport builds the whole blockchain in a single binary, we can access all the functionality from the CLI as well. So chainD has namespace called query, right? And query has a bunch of modules here, and one of them is our blog module, right? So if we go into the blog module, we'll see that we have one command called posts, which is exactly this, and it runs the same posts keeper function. So from posts, we'll get Starport hello. So same thing as here, except it's returned not as JSON. So that's good, but let's do something more interesting, right? So we figure out how to query the chain for data, but we don't have any data on chain, right? But how the interaction happens is a user broadcasts transaction with messages, right? So we need a way to write messages. So Starport, of course, has a command that does exactly that. So Starport can scaffold a message for us. And before we do that, let's actually add everything to git commit so that we can see all of the changes. So Starport message, and this message will be create post, because we want to create posts, and it will accept title and body similarly to what we have in a proto file, right? But we also need to specify that it's going to be generated in the blog module. So it will create quite a few files for the message, and we can see them here. So it modified TX proto. Okay, interesting. Genesis file or directory. Okay, let's wait for it to actually finish scaffolding. But what we see Starport already added is create post RPC in the message service. So this is the message type that you can now create and broadcast. So let's wait for Starport to build the chain. Takes a while, but it automatically assigns creator, which is the address of the person, or I mean the entity who signed the transaction with the message. So okay, it built the chain, and now we can see, we can actually use the TX namespace of the blog module and see that we now have create post. So what Starport message did is it added an RPC in the service called message, which registers a message on chain, and it added a couple of lines to the handler.go. So let's use the CLI to create a message. And the way we do it is by using one of the commands that were also scaffolded which is create post, right? So this file was generated, and now we have this command, right? Create post. And create post accepts title and a body. So let's just say foo bar. And whenever we broadcast transactions, we need to make sure that we pass who is signing the transaction. So in the config YAML, which acts as a configuration file for development purposes, right? We have accounts, we can add more accounts here. But one of the accounts is Alice. So we'll use from flag and pass Alice. And let's see what it created, right? So it generated a transaction. And the interesting bit here is, well, of course, it has foo and bar as title and body, because that's what the CLI command does, right? It assigns arguments that we pass to the variables and to the values into the transaction. But what we're interested in is the type, right? So this type reflects the proto package name, which is Alice chain blog. You can see it here, right? Alice chain blog. And then we see the type of the message. So message create post. And this type is important because the first bit is refers to where this message will be routed to in terms of modules, right? It's going to be routed to blog module. But the actual type lets your blockchain know how to handle this message. So we can see that there's like switch statement essentially, and for each message type, it does something. And more often than not, it calls a keeper method. In this case, it's create post, right? So we can go into the keeper package and we see that there's a message server create post, and this function gets called whenever a transaction with a message with a particular message is processed, right? Right now it doesn't do anything because it's just a scaffolding, right? So it's kind of waiting for us to implement it, but it will still get handled. So if we type yes and actually broadcast the message, what it will do is it will get included into the block and then processed by the handler. Handler will call the create post keeper method, and it's not going to do anything. But it's kind of important to understand that queries first are defined in the query service in Proto, right? You need to provide an HTTP endpoint so that your clients can query the data in the browser, and each RPC in the query service calls a particular keeper function that returns data. Often it returns data from the state because it's rarely you just want the static data. But this is where you will fetch the data from the state and return it back. When you broadcast transactions, they include messages, and each message is represented as an RPC in the service called message. And each RPC is effectively kind of refers to a type, and based on this type, a message is routed to a particular, is routed to a particular module, and within the module, it's dispatched and called and calls a particular keeper method. So now let's actually implement what we want, right? So we're going to make some modifications here. First of all, we need to make sure that we return the ID of the post. So we will add that. So we int 64 ID 1 and change that. And the next step is we actually need to populate the create post method, because right now it's empty and we're not going to need that. What we want is we want to add posts to our state, right? So the first thing we actually need to take the information from the message that was broadcasted. So message contains title and body. It also contains creator. So let's create a variable called post, right? It's of type post, and it's going to have creator, and we'll take it from the message, and have title, also from the message, and body. So this message variable is from the arguments of this function. So it will have creator, title, and body. And what we need to do is we need to append this post to our state. So even though the state is a key value store, we're going to, for each new post, we'll have a separate key. And the key will be post-id, and the value will be the value of the message. So we'll have append post method. We'll take a context, and we'll pass the post. And this append post, since we want our function to return ID, we also need to get ID, right? And let's return ID since that's our response type. So if you build it right now, it will fail because we don't have the post type. We don't have append post right now. It's kind of like we drafted this, right? Append post doesn't exist yet. So first thing we need to do is we need to go back in proto files and create a new file. And let's call it post.proto. And proto files define types, right? So they define messages, Cosmos SDK messages. They define queries, but they also define regular Go types. So syntax proto3. And this package will be Alice, chain, and block, so that we kind of know like username, repository name, and then the module, so that we know exactly where it is. And we'll define the type. So we know that it has a creator, right? It has ID, which will be just auto-incremented by our chain, and has title and body. Right? We also need to pass where this code will be generated, right? So from each proto file, Starport will use proto-C to generate pb.go files, which will actually contain types, right? And in this case, we just use go package option and pass the module path where we want this code to be generated. So it's Alice chain, X block, and types. So the types package, typo. So the types package will now contain a type called post. So this should no longer throw an error because we've implemented the type. But now we need to actually do something about appending the post, right? So right now it's not implemented. Let's define how it's going to be stored, right? Store, as I said, is a key value database. So we cannot just append data, right? We need to assign it to assign each bit of data to a particular key, and we have keys file in the types package. It's just a convention to define keys here. So let's do that. So we'll define two keys, one for the actual post. So post value dash, it's going to be a prefix that we store posts under, and we'll also have post count. So the reason why we need that is we need to increment posts, and we need to store how many posts are there in the store. Instead of kind of counting them one by one, we'll just store the number of posts. So the way it will be stored in the database is post value -1-2, and each post will have a unique key associated with it. So now that it's done, let's actually implement the append post function, right? And since this function, it's a keeper function, and to maintain some sort of order in this project, I'll just create a new file called post and start thinking about what we need to do, right? Well, since we need to assign each post to a particular key, we need to get the count of posts, right? So we need to count posts, right? We need to get the latest count, get the latest count of posts, right? Then we actually need to set the value of the post. Well, get the then when we set, we need to set the count, updated count. So if that's 3, then this would be like 4. I mean, it depends on the implementation, but we'll update the count in the store, right? And we will return the count. This is what we need to do. So let's first implement the get kind of the function that returns that count of posts. So we already have it here, so that we don't make any mistakes, but let's just kind of write it down. So it's a keeper function called get post count. Get post count. It takes context. Context essentially contains all of the kind of information about the transaction height, block height, etc. Right, and our count will be an integer. And what we need is we first need to get the reference to the store, right? So let's do that. Probably not going to type it everything. We'll just copy and paste. But essentially, what this does is it gets the value of the post count key from the store, stores it. Right. Now, what we need to do is we need to convert the post count to bytes, since that's how it's stored. I'll just copy and paste this. So we take the value and convert the key under which we store the count and convert it into bytes. Then we effectively get the value of the count. So we have a store, and the store has a couple of methods, so we can probably see them. Anyway, it has get and set methods. So now we get value of the count using the prefix, right? And we convert it into bytes. So now if it's nil, then it's essentially 0. So there were no posts in the store, so we can start counting from 0. But if it is, then we actually need to convert it into a string, right? So we do that, and we handle error. So if we cannot decode, then I mean, something happened. Technically, it shouldn't happen, but we'll still handle the error, and we return count as an int, right? So this should return the latest count of posts, right? So what we did is we effectively used the key for under which we store the count, right? Post count. We convert it into bytes, then we got the value that was stored, that is stored under this key, and we got the value back, right? And initially it's going to be 0, but we'll kind of increment it, and it's just an incrementing integer, essentially, right? So this step is done. Now we need to set the value, right? So we have this function append post, right? And we pass the post type to this function. So what we will implement now is a function called setPost. Well, yeah, we need to first set the new count. So let's not spend time on this, just copy and paste, but kind of figure out what we're doing here. So this is actually the last step, right? So we set the count after we set the post. So initially it's going to be 0, then we set the post, and then we update the count. So now it's going to be, instead of 0, it's going to be 1, and refers to the number of posts we have, right? So it's pretty similar. We get the key, convert it into bytes, but instead of getting, we actually set the value to a particular count, right? And we can implement the actual append post method by using these two functions. Update everything. So the append post actually does implements the logic of adding the post to the store, right? So first get the post count. Initially, it's going to be 0 because it will return nothing. 1 second, typo. New store. So for the first post, it's going to be, it's going to not find anything in the store. It will return 0. We'll use that 0, assign it as an ID to our post. Then we'll get the store using, get the key, convert the key into bytes, and then we will set the post value, which is appended value, using the key, right? And then we update the post count, which is count plus 1. So that next time when we add new post, we'll do all over again, get 1, assign it as 1, and set the count to 2. So hopefully we didn't make any mistakes, but let's update the chain. The module path, since we have the chain, the project name is chain, but the module is blog. Update this, and let's see if we made any mistakes. So it's building proto right now. And let's wait for it to complete. So again, kind of going over this, this is this is very basic, but it shows the principle of operation, right? So you can, by the way, I forgot to save this file as well. So now we see that we don't have any errors because we implement the post type in our proto file. It generated post pb.go, right? And we manually implemented append post function, which returns ID. And message create post is the type that gets returned, right? So we can see that this function create post should return response, and return response is a integer ID. So let's see. Okay, it's building fine. If we try creating it again, we broadcast a message, and let's see it here. And it doesn't show up because we didn't implement that, right? We still have hello Starport. So what we now need to do is we need to implement the query. We already have all the boilerplate code, but we need to fetch the data from the store, and let's do that. So as we remember, it essentially calls this keeper method called posts, right? And I'm just going to copy paste, but then explain what's going on here. So quite a few things here, but first of all, let's address the errors, right? When we query, typically we don't get just a single value, right? When we get posts, it could be like 100 or 1,000 posts. So we need pagination by default. I actually think Starport query has pagination. Yeah, I mean, we could have passed paginated flag, but let's just do it manually. What we have is Cosmos base query is already imported. So this is part of Cosmos SDK, so we don't need to implement that. But when we query for post, you can actually specify a page that you want to get in return. So if the response is paginated, you can get a particular page. And as a response, instead of getting title and a body, we'll get a list, an array of post, right? And it's going to be called post. And we'll also return pagination information, so which page it is imported from Cosmos. So this is not going to work because this protofile doesn't know post type, right? So first we imported pagination previously, but now we need to import the post type. And that's actually why it's important to define it as protofile, so that you can use it as a return type for your query, right? You can use it both in your Go code, of course, and use it in protofiles. So you need to import blog post proto, since this is root of our protofiles. We specify the module, the directory in which this is stored, and let's see if it builds. I mean, it complains about not having access to this, but it's only because Starport has its built-in. So instead of you have to manually kind of install proto-C and all these files, which is kind of challenging especially for new developers, we bundle both the proto-C binary and all required proto files inside Starport, so you don't need to install anything. So it looks like now it's building well. So let's go through what actually happens. So first, we kind of check that request is not nil, and we get reference to the store, right? We get the prefix, so our posts are stored under post key, right? If we go here, see post key is post value dash, and we paginate. This is kind of like boilerplate implementation of pagination. Cosmos SDK includes that by default. And in the posts array, we just append all the posts that we got from the store, right? So we retrieve all the posts, append them, and return. So this function post is used both by the CLI, so query posts call this function, right? And it's also used by gRPC HTTP API, and it is mapped essentially to this RPC, right? So if we now visit our endpoint and refresh, it's empty because the state was cleared, but then we run again, see if it gets added. and we see that the post has been appended. We can do it multiple times. We can actually switch it up and like hello Starport, and then from Bob, from a different user, and it will have a different creator address, right? So, so yeah, this is the way you kind of build pretty much everything, right? The process is the same. Whatever you build, you implement messages to affect the state, and you implement queries to get data back, and the whole kind of the bulk of the logic is stored in, is implemented in these keeper keeper methods that deal with state, write stuff, and yeah, that's how you build pretty much everything. I mean, of course, this is a very, very simple example, but I think it kind of gives an understanding of what goes where, right? Like the whole process of broadcasting a transaction with messages and how messages are dispatched and how they can affect the state. So now let's kind of review all the features, not all the features, of course, but some of the features that Starport includes. So of course, we've saved a bunch of time not having to implement the boilerplate code, right? So the module was created automatically, and the message, the query, everything was created automatically, and the only thing we needed to implement is actually the post functions that we use to do the business logic, right? In this case, very simple, just appending posts to the state. But of course, we couldn't have scaffolded that. But everything else was created, right? So we didn't need to write all of this. And actually, Starport, of course, includes logic that will do it automatically. So let's add all of this to Git so that we can see what has changed. Created posts. And now what we'll do is we'll use Starport type command. And type does a lot more than message and query. It scaffolds more code, but we're going to do the same thing. So post title body just to compare, right? And we'll scaffold it in the chain module, right? So chain module is still pretty much empty, doesn't have anything. So let's scaffold it in the chain module just to compare. So we can see that it created a bunch of things, but some of the files are similar, right? Because what type command does is it creates queries, messages, creates all of the functionality you need to implement CRUD, right? So it creates, in this case, it creates posts, deletes posts, updates them, and allows you to read them through queries, right? So it also implemented query post, and we can see all of the things. Some of the things here we actually implemented, but yeah, this single command effectively does everything we did previously and a bit more with deleting items. And you can actually use that to, if you have something that is CRUD-like, you can use the type command to quickly scaffold all this functionality. So we also have post go file, and it's similar, but it also has functions for setting and removing posts, right? I mean, you can scaffold it for anything, right? You can type, I don't know, product name, description, etc. Right? So you can quickly scaffold a lot of code, and that's very useful if you go through tutorials, right? So for example, we have quite a few tutorials, and I strongly recommend you to check out IBC Hello World. So this tutorial actually is kind of similar to what we went through earlier, but it's IBC enabled. So instead of having one chain, you have two chains, and they're sending packets of data through the IBC protocol. And a bit more advanced tutorial which implements a DEX. So if we go into this section, we'll see that it heavily uses Starport scaffolding capabilities to create modules, create different types, and type functionality is useful because we don't have to re-implement the logic for setting, getting information from the store. And it also scaffolds packets, messages. So it roughly scaffolds around 3,000 or 4,000 lines of code. So this time is all saved, not having to write it by hand. So that's super useful. What's interesting is that, of course, all these features are incredibly useful for blockchain developers, right? When you are building a chain, you don't want to write it by hand, but also we generate the client code for the blockchain that you're creating. So as you can see, we wrote some code, right? And Starport automatically scaffolded clients for the code we wrote, right? So we have two modules, blog and chain, and for both, Starport created TypeScript and Vuex clients. So this is incredibly useful because the way you interact with your chain from the browser, for example, is you need to encode the data that you're sending messages using Proto, right? So all of this is automated by Starport, and essentially what you have in the end is simple Vuex actions like query posts, which will get post information from the chain, right? And even more importantly, you have an action that will broadcast the message, right? So what it will do is it will take the data, in this case it's title and body, and encode it, sign it, and broadcast it, right? So all of this you don't need to do. What you need to do is just type send message, create post, pass title and body, broadcast it, and it's going to be on chain. So you can use, of course, if you use Vue, then Vuex will most likely be what you need to import. But if you're not using Vuex, you can still use TypeScript, which is also generated. So whenever you change something in your proto files, like add a new RPC, Starport will automatically regenerate clients. And what's cool is that you can actually publish this directory, right, on NPM, for example. So anyone can import this library and build a client for your chain, for example. So, of course, there's not only the store with API client, but we also have a template. So if we go into the Vue directory and we first install dependencies and then start, I mean, it's going to take a while, but in the meantime, let's kind of inspect what's going on here, right? So it's a very simple Vue template that essentially implements all the basic features kind of you expect from an application, right? So once it's done, we'll see it in action, but it has a couple of components for sending tokens, for listing transactions. It has components for signing in. So it has a simple wallet. And what's cool, it's also integrated with Kepler. So this is not meant as a fully featured application because Starport doesn't know what your chain needs to do, right? But it definitely acts as a great starting point. So you can use this. And if you don't need like the token send component, you can just like comment it out or remove and build your functionality. But initially, keeping wallet is probably a good idea, so that you don't have to implement that. You don't have to think how keys are stored, how to integrate with Kepler, all of these things all already there. So you can focus on building the functionality. So if it's, I don't know, an NFT platform, then you do that. If it's a DEX, then you build a swap component or something. And then later on, you can like restyle it and actually adapt it to what you need. But the purpose of all of this, as with everything else here, is to help you not write code that is kind of common and boilerplate, right? But also allow you to edit it, right? So it's not something monolithic, it's all componentized, so you can move stuff around, edit it, or remove it altogether and just keep the store, for example. So it's super useful this way. And also, while it's building, docs are actually very important as well, right? So we can, if we go back to the 1317, it really helps you understand what's available on your chain, all the modules. So for example, a bunch of modules like for governance, for bank are already imported, and you can make queries to them. And yeah, you can pretty much see what's available on your chain. So once it's finally builds the thing, we can actually open it. And yeah, we have this simple UI, and we can create a new wallet, use Kepler. Let's use Kepler. So it's already integrated. Approve, and yeah, now you have your new app in Kepler. I mean, it doesn't have any tokens, but the integration is already there, so you don't need to worry about how to integrate with Kepler. And since we already have a faucet, we can actually use that to send tokens to your Kepler account. So you see that right now it's kind of empty, right? It doesn't have anything. Let's send tokens to it. And now if we refresh, okay, for some reason it didn't copy the address. Let's paste the right address and try it again. And now we have stake and we have tokens. You can send them around. So these are the tokens of the chain you're running locally, already integrated with Kepler. So that's pretty cool. And of course, if you refresh and open, you can see we received tokens from the faucet. Right now we can use this UI, and it will prompt you for confirmation from Kepler because it's integrated, right? So that's really cool. Since we scaffolded posts, I mean, we use Starport type command to scaffold post. It also created a form for us. If we don't like that, we can, actually remove it as well. So this is not something you necessarily need. You can just remove it. and it's going to rebuild eventually. Now we can do anything we want here. Another cool feature of Starport is actually that it has relayer built in. So most likely when you build a chain, what you want is IBC, right? So you don't want to just build a chain, you want to build an IBC-enabled chain, and the Hello World tutorial will actually tell you much more how to start building that. But for IBC to function properly, you need a relayer, which is an off-chain program that essentially acts as a transport layer, transfer data from one place, transfers IBC packets from one chain to another. Starport has two commands for this Starport relayer: configure and connect. And so configure command sets up connection between two chains, and connect actually connects. I'm not going to demo it right now. There's a video on YouTube how to do it. It's very simple. We just run configure. It prompts you for a bunch of things, right? And then it establishes a connection. By default, it will connect to the chain you're running locally and Cosmos Hub. To actually send tokens to Cosmos Hub, you will need to use real atoms because it's mainnet, right? So Cosmos Hub doesn't have a faucet. So you will need to populate your, send just a bit of atoms if you want to send tokens to Cosmos Hub, but instead you can actually pass any RPC and connect to chains. Like in this example, you will connect to locally running chains together. So this is super useful for development purposes because when you build an IBC module, you want to test it. This is probably the easiest way to test IBC modules. So the last thing I'm going to demo is actually use this online version of Starport, and the reason for that is we want it to be online, so all of this functionality works locally, but on a server, right? You need to have a server. Here we're just going to use Gitpod, and what I'm going to demo is a proof of concept we worked on that lets you launch chains. So right now it's in a proof of concept stage, but we are actively working on a production-ready version of this, which will be released later this year. I'm going to very simply demo it, how it works right now. So this is very useful if you just want to launch a chain properly, like and with friends or like with strangers. So Starport network set of commands lets you create a chain and join the chain as a validator. So let's quickly do that. So we have two environments open. They're not connected with each other. And let's just launch Gaia quickly. All right, so chain has create command. Let's use help. So it accepts chain ID and source, and we're just gonna come up with like, I don't know, foo Gaia test net 42. And we're gonna pass URL to the source code of Gaia. I mean, you can, of course, scaffold the chain, push it to GitHub, and use that, but we can use Gaia. So let's create local account, created an account for us because all of this is powered by Starport Network blockchain proof of concept currently online. So what this does is it essentially takes the source code of the chain, downloads it, initializes, creates the genesis, and sends a message to Starport Network that you are kind of initializing the launch of a chain as a coordinator. And this is super useful because it automates a very tedious process of launching a chain, right? So while it's doing that, the second environment is identical. It doesn't have anything here, but it has Starport network chain as well. So all of this is available. So let's wait for it to initialize. So it's telling me that it successfully created the Genesis file, right? So the chain, it checked that the chain is a proper Cosmos SDK chain that it can build. And we're acting as a coordinator, and we submit a network to be published on SPN, Starport network. So now what we can do is we can list chains. I mean, there are a bunch of chains people launched, but we have our Gaia testnet 42 here. Right? It doesn't have any validators, doesn't have anything. So let's join this chain as a validator, Gaia testnet 42. So we're going to join this testnet as a validator here from the same account as we published the chain. And here we're going to do the same, but from an account that, I mean, from a separate server, right? These are two separate servers. And yeah, I'll just use the default values. So we're setting up a validator essentially on this local machine. And we're doing that in another terminal as well. So we proposed ourselves to be as a validator, and since we're the coordinator, it automatically approved our proposal. So the system works. Validators propose themselves as candidates to be included, and the first one was approved, right? So the proposal automatically added account and validator. As soon as it's approved, all of this will be included into the Genesis, right? And let's wait for the second chain to do the same. So we're also going to use the same default values. So this is kind of like an application process for a validator, right? It tells it tells information about itself, and then it proposes. So the proposal has been submitted, so we can see that we now have 2 more proposals, and we can approve them by using ID and Gaia testnet 42. First, we need to pass So as a coordinator, we're right now approving proposal of this machine, right, of this validator. And what Starport does is it actually tests that this Genesis file that was generated is valid, right? And now if we, again, list all proposals, we see that all of them are approved. And what we can do now is we can actually start the chain. So we run this command, start, and it will start the node. Right now, only this machine is online, and we can see that blocks are not generated. We have only 50%, which is not enough for the chain to start. So let's use the same command here, Starport network chain start, Gaia testnet 42, and let's see what happens. So it also starts a node, add peers, and we can see that 100 peers are online, and our chain has started. So we are generating blocks, and we can submit transactions. This is a very handy way of kind of testing your network online. So after you build your project, you can launch it and test all the functionality and share it. And I mean, if you run it from a server, you can you can actually keep it running. Yeah, well, you need to specify home address, but home directory, but so we killed one node, and the other, of course, stopped producing blocks because it doesn't have enough. But once we, it takes a couple of times because it's running on Gitpod, but once we start the node again, we'll see that it will continue generating blocks. So yeah, this is a super helpful, kind of easy way to start a chain without pretty much doing anything. And we're actually working on a production version of this. So yeah, just to kind of recap what we did is we reviewed all the, well, not all, but some of the more interesting features of Starport, right? It allows you to very quickly create a new chain, add modules, add messages, types. It generates TypeScript and Vuex clients. It has a Vue template, generates the docs. It has the functionality to help you launch your chain online for testing purposes right now. But so yeah, that's pretty much it. Well, if there are any questions, I'd be more than happy to answer them. But yeah, that's pretty much it. Thanks for watching.
Thanks, Dennis. I think most of the questions have been answered on YouTube. So if there's any pending questions, we would direct them to you. And hope to have you around from now until the end of the HackAtom. Thank you so much.
Yeah, absolutely happy to be here.
All right. Okay. Hi, everyone. So as usual, we're going to have a few announcements before our next session. So along the way, I would make some Vietnamese translation for our Vietnamese participants. So today is the last training session that we have for the HackAtom, and we will have 1 week approximately from now until the end of the HackAtom. And the closing date is July the 2nd, midnight time by Vietnam time. So please, from now until then, please make sure that you will be able to participate in the mentoring slots with our mentors. We have scheduled almost every day, with the mentors around nighttime in Vietnam. So please make the most of this time and discuss and get consulted with the mentors to make sure that you are best prepared for the HackAtom. Xin chào các bạn, thì chúng ta có một số thông báo cuối cùng trước khi chuẩn bị cho kỳ thi sắp tới. Thì hiện nay như các bạn cũng đã biết, đây là buổi đào tạo cuối cùng của chương trình HackAtom và chúng ta sẽ còn khoảng gần 10 ngày nữa, khoảng hơn 1 tuần nữa để đến khi đóng đơn của cuộc thi này. Thế nên là từ giờ tới lúc đó các bạn hãy vui lòng lưu ý là trong lịch đào tạo của chương trình thì từ bây giờ tới cuối chương trình, mỗi một ngày sẽ có từ 1 tới 2 các cái slot với các anh chị mentor và các anh chị nói tiếng Việt. Thì các bạn vui lòng check trong lịch của HackAtom và tham gia những cái buổi mentoring này để có thể được đào tạo, được cố vấn thêm từ các chuyên gia, từ các cố vấn nha. Thời gian đóng đơn của chúng ta sẽ là nửa đêm của ngày 2 tháng 7 theo giờ Việt Nam. Mong các bạn lưu ý. Also, we have shared with you in our email the announcements about our, our training sessions, and we also provide the link of the previous training sessions for your reference. So please, maybe rewatch these videos if needed, and also join our Discord channel, talk with our mentors, with the community, to make sure that you have all the resources needed for your submission. Và các bạn ơi, chúng ta cũng có những cái thông báo bằng email, trong đó có nêu rõ những cái đường link của các cái buổi đào tạo này, thì các bạn có thể xem lại những buổi đào tạo này qua link trên YouTube. Và ngoài ra thì tham gia kênh Discord với chúng tôi và họ trên Zalo để có thể là trao đổi với các anh chị mentor, trao đổi với cộng đồng, để các bạn có thể có những cái nguồn lực tốt nhất để tham gia để nộp bài của chúng ta với cuộc HackAtom lần này nha. And last but not least, for those who haven't added our HackAtom Google Calendar, please do so. You can find the link from our email announcement. And we hope to see you, in our upcoming mentoring slots, and all the best of luck for your HackAtom submissions. Và thông báo cuối cùng đó là các bạn nào chưa add cái lịch Google Calendar của HackAtom thì vui lòng tìm link trong email để có thể tham gia với chúng tôi, và nhất là những cái buổi mentoring từ giờ tới lúc mà chuẩn bị nộp bài thi nhé. thì các bạn vui lòng là chúng ta hãy cố gắng chuẩn bị thật là tốt với cái bài thi của chúng ta, và chúc các bạn may mắn tại cuộc thi HackAtom lần này. So that's all for now. Thank you very much for your time today, and we hope to see you around very soon. Good luck and bye bye. Cảm ơn các bạn đã theo chương trình ạ.